Okay, so this presentation is to help you get through the Unit 3 lab, the titration lab. So let's start by gathering our materials. Right? If you're doing the lab on time, you'll be able to grab this right off the class plan. You could click here on 3.07, or just remember that it is called 3.07, and then you can find it on the calendar, which would be Tuesday the 3rd of November. So I'm going to click on there, and I'm going to click more so I can see everything. And then start out in lesson introduction. So this lab is going to be not a Dropbox submission, but you're going to post your responses as a discussion to the class. But you'll want the lab report because that's where the answers to your discussion posts are going to come from. So if you skip to the end of the lesson introduction, make sure you grab this Pen 3.07 LRD. All right. You open that up, it looks something like this. And I will walk you through the entire first half of this lab, and then you'll be on your own for the second part. All right, especially this part here, listing the ppm. Not as difficult as it seems, but it seemed a little unclear to me at first. Another thing I set up was a quick table. In your lab manual, it talks you through writing this stuff down, recording it somewhere, because you're going to need this information to answer the questions. All right. So, and we'll fill in sample A together. You'll be on your own for sample B. And other stuff, you're going to need physical materials. You're going to need your alkalinity test kit, right, which has a couple of samples A and B in there, and then some chemicals that we need to do this. You are also going to want your lab manual open to Lab 9, Titration, Testing, and Water Quality. All right, this front page here, some important things to make note of are these pH numbers. All right, the first chemical that we add, the first indicator that we add is called phenolphthalein. All right, and it's spelled right there, really strange word. How you say it is phenolphthalein. All right, it indicates it'll turn a basic or an alkaline solution pink or red if it is above a pH of 8.3, all right? And then it goes clear if the pH hits 8.3 or drops below that, all right? So then we're gonna see that color change. Another pH to make note of, as later we're gonna add a second indicator. The name of it's actually in the procedure, but the second indicator is this total alkalinity indicator. And this is an indicator that will turn red if the pH goes below 4.5, right? And it's going to start out with a green color when it's above 4.5. So we'll see that as we go through sample A. So I'm going to flip to my procedure here. So you'll want to read through this and follow along with me, all right? But I'm going to actually put my equipment out in the center here. So I'm grabbing one of the vials. You should have a few of these in your kit. You'll need 2 of them for this lab, or you'll have to wash out in between. So I'm going to grab this vial, and then it says to add 25 milliliters of water sample A. Okay, so I have alkalinity sample A. I'm going to add 25 milliliters. So there's a little safety cap thing on here. Make sure you peel that off. Or you may have to punch through it. Depends on how cooperative it is. There is no little thing to grab from, so I just ended up punching through. And then I'm going to add 25 milliliters to my vial. And a little bit more. Okay, when measuring this, you do want it flat on the ground, right, so that you can tell that you actually get there correctly. So there's my 25 milliliters. I'm going to keep my cap handy. I don't necessarily need it, but it's always a good idea if you're shaking things to maybe put the cap back on. Then it says add 3 drops of the phenolphthalein indicator. So phenolphthalein, that has a seal to break as well. Yep. All right, so with working with the droppers, don't squeeze until you have it flipped over. That way you can keep a good count on how many you add. So there's 1, 2, 3. I didn't even have to squeeze to get it to drop. And you can almost see a little bit of pink there, but not quite. So it does say the sample should turn and remain pinkish red. More drops of indicator may be necessary to achieve a color change. So I'm going to add another one and see if that gets me there. And I'll keep doing that until I get it to turn nice and pink. Let's do one more. I want it to look like the picture in the lab manual, so I'm going to keep going. I definitely see a pinkish hue going on now, but I kind of want it to be a little bit brighter. Let's see. I know you guys can see pink on your end, so I think this will work. I'm going to try changing the exposure a little so it's a little brighter for you. Try one more. All right, well, it's definitely staying light pink, and it's not going back to clear. All right, so I think in the end I might have added 8 or 9 drops, but just make sure that it's not going back to clear after it sits there for a second and the pink stays. Okay, so now on to step 3, add 1 drop of alkalinity Trident low, then swirl, observe for a change, and then add the next drop. All right, so we're going to keep doing this. We're going to add drops until we see this pink color disappear. Okay, so alkalinity titrant low, that's this guy. This whole 10 ppm is going to be something we use later. But let me add, again, here you got to be careful. Try to ensure that it's only 1 drop at a time. Oh, I accidentally got 2, so I'm going to make note of that. So I added 2 drops. I'm just keeping track of it on the board here. I'm going to swirl it. It goes clear. Does it stay clear? All right, well, I guess 2 drops is enough to make it clear. Hopefully I didn't only need 1. So my P alkalinity, or the number of drops to get the color change with the phenolphthalein, I'm going to record as 2. All right. Now, what this means is that the pH of my sample should be at 8.3. Because that's when the color change occurs in for phenolphthalein. So to double check and make sure that I haven't goofed anything up, there are pH strips, right, in your kit. And it says use pH paper to check that the pH of the sample is 8.3. On the bag of your pH strips, there's some instructions for doing this. It says dip test strip in the solution for 3 seconds so all color zones are immersed. Compare unprinted indicator zone to color scale and determine the pH value. Okay, so the zone we're going to be looking at is this one, the one that doesn't have a number on it. But we're going to make sure that the whole thing gets submerged. So I'm going to bend this a little bit and throw it in here. Make sure it gets all the colors get changed. Let's see. I lost my piece in there. pH of 8.3. Not an awfully high pH. You probably do want to rinse your hands after this if you have to get in there like I am. Let's see if I can use these scissors to pull it out. All right. So, looking at that center range, honestly, I'd say the color is probably somewhere around 7. It's not quite 8. So what this is actually making me think is that maybe I had too much and maybe I just needed 1 drop. So I have enough of the solution A. I'm going to quickly start over again since I might have accidentally added too much titrant low at the beginning because I got 2 drops in instead of 1. Luckily, I have enough to do that. This is something you may run into having to do too while you're working. Okay. Yeah, because actually color-wise, I'd say my pH shift looks like maybe it's more around 5. So phenolphthalein indicator, putting in 3 drops again, which still is not giving me much pink color. This isn't affecting your pH at all. It just reacts with, it can tell that the base is in there and therefore changes color. All right, so there's pink again. And my titrant low. I have a little bit on the top, so I'm going to rinse that off. I'm just dabbing off this little bubble that I have up top there because I don't want extra in there that I don't necessarily need. All right, now I'm going to try really carefully not to get more than 1 drop this time. There we go, just 1. And swirl. Let's see. That is clear. So this time I think, so I'm going to adjust what I wrote. You only need 1 drop. And you can always double check me with your kits. On that titrant low, and then let's check our pH now and make sure that we are not necessarily as low as last time. There we go, make sure all the colors are submerged. 1000, 1003. Try to get this up. If the scissors worked well. Don't cut through it, just use them to just barely grasp it, maybe. Using them more as tweezers than. And this time I'm a little bit lighter than the time before. All right, so I at least know for sure that since I can't do less than 1 drop, 1 drop's definitely getting me past 8.3. So more acidic than 8.3, and that's why I'm seeing the color change. Okay. So now we are on step 6. Add 3 drops of the total alkalinity indicator. Wipe up my solution here. So that's this guy. Oh, I'm sorry, I'm not even showing this to you. So if you look at my 2 strips, that's the new one. That's the old one. It's a little bit lighter, so I'd say it's probably less acidic. Okay. And now I'm going to add the total alkalinity indicator. Again, I'm going to start with 3 drops. It says that the indicator will turn red when the pH is 4.5. Currently, the sample should turn green because we're above that. So 1, 2, 3. I'm going to swirl it, make sure the color change stays. I'd actually call this more blue than green, but it's not red. All right. So now it says add 1 drop of alkalinity titrant low. Then swirl, observe for color change, and then continue. So we're looking for now the color to change to red. Okay. So again, be really careful. Try to get only 1 drop. And 1. I'm going to swirl. Still blue. So I got 1 drop. Two drops, still blue. 3 drops, still blue. A little bit more exciting than the phenolphthalein. 4 drops. 5 drops. And number 6. I'm actually going to cross here, so there's 5 and 6. And I'm just going to keep adding 1 drop at a time and tallying it up until it finally turns red. And 9. This one's number 10. So definitely, it's taking a while for that change between pH 8.3 and 4.5. Right? There should be a vocab term that you're thinking about here, something in the solution that is holding the pH as close to neutral as possible, or holding it in a range for a longer period of time. Okay, so that was drop 11. So this part is definitely going to be the longer part of the lab. All right, and you just got to keep doing this until it turns red. And I haven't done it before, so I have no idea if we're close. I feel like we have to be getting pretty close. That was 14. And there's 15. $16. 17. 18. 19. 20. 21. 22. 23. 24. 25. Say I'm definitely getting a little bit lighter in blue, so we should be getting close, I think. 26. Oh, that almost went clear. 27. Definitely barely any of that kind of greenish blue color in there anymore. See if we can get it red this time. 28. 29. 30. I'm going to give it a couple more. If I don't get red, I'm going to test the pH just to make sure there's not a mistake in the lab manual about what color it should change. One. 2. If it doesn't go red now, I'm going to test my pH, and if it's a lot lower, then I know at 28 it was actually when we experienced the color change. So there's 33. Let's see what pH we have. Not at 4.5 yet, then we will continue to add drops. So 1, 1,000, 2, 1,000, 3, 1,000. Let's get this guy out of here. Based on the color that I am seeing, it's kind of a bright orange yellow, which I would say would be between 4 and 3. So what that makes me believe is that the lab manual misled us by saying that it should turn red, and really it kind of turns yellow. So I'm going to erase back to 28 and call that my number of drops. That's when the color change originally took full effect, right? All right, so based on my color there, we probably had a pH of 6 when we started. It took 28 drops to get the next color change, and we'll call it 4. We were unable to measure the pH then, but this way, when you guys do it, you'll know that it's not going to turn red. It's going to go kind of clearish, yellowish when you do reach that 4.5 pH level. All right. So you're going to repeat this exact same procedure with alkalinity sample B. Okay, so either clean out and dry this container and reuse it, or grab another one. When you're done, you're going to want to clean out and dry all of them. And then do the exact same thing with sample B, right? A and B have different concentrations of sodium carbonate in them, which is going to change the number of drops it takes, right? And then let's look at the questions you've got to answer, because these are the things that you're going to include in your post. So list the values for T alkalinity for sample A and sample B. All right, so for me, I'll answer this for sample A. For sample A total of 29 drops were required to get the pH below 4.5. All right, now I said 29 because initially it took 1 drop to get down to 8.3, all right? And then 28 to get down to the 4.5 color change. Now, if you remember on the bottle, the alkalinity titrant low, each drop is, for every drop you have to have, that's like having an equivalent of 10 parts per million of calcium carbonate in the water. All right? It says calcium carbonate because that's usually what's naturally in our waters and tap water and things like that that acts as a buffer. All right? We were using sodium carbonate, but if you look at the formula, there's only 1 carbonate in both formulas, so that's okay. We can think about that as a direct conversion. The sodium and the calcium part doesn't play any effect on this. It's the carbonate that we're really dealing with. So what that means for sample A, if each drop is 10 parts per million, total in our sample, we should have 29 times 10. (290 ppm of sodium carbonate. And there's a 2 there. Okay. And then when you do this for sample B, sorry, that should be for sample A. When you do it for sample B, you'll do the same thing. You'll count up your total number of drops, multiply by 10 to get your parts per million. Okay? So, this writing the equation. The equation is written in your lab manual, so you don't need to necessarily do this on your own. But the key is, once you know this dissociation and you look at your samples from before, all right, particularly the number of drops for the phenolphthalein part, that's going to help you decide which of your solutions was most alkaline at the beginning, right? Because phenolphthalein measures bases or alkaline solutions. So the more drops with the phenolphthalein for the change should indicate the more basic solution. Then, so you can't answer 2 and 3 until you have data for both. But for question 2, your focus is going to be on the drops with phenolphthalein. I'm not writing it all out because I probably won't spell it right. But the drops with phenolphthalein, that's going to help you decide which of your solutions was more alkaline, and then explain how you know that. Then the third question relates to real-world application, right? So these were prepared samples for you. If you were to work in water treatment or water quality company, something like that, this is something you would do. And this is something people who have that job do all the time, all right? So the big thing down here is if a worker studied 2 lakes and Lake X had a greater ppm of calcium carbonate than Lake Z, which of the 2 lakes would be able to withstand a greater amount of acid rain, all right? To help you think about this, the acid we were dealing with is your alkalinity titrant low, all right? The indicator, so the number of drops that are going to help with us, is how long it takes to switch over this total alkalinity indicator, all right? Because this is where we're really seeing the effect of the acid and whether or not it's going to make the water, the sample, acidic itself, okay? So for the third question, you're going to want to use your drops with the total alkalinity indicator as a way to answer this question. Be sure for both of these questions to explain why you're saying what you're saying. Use the evidence from the lab. How does it support what you're saying? That's what I'm really going to look for when I'm grading your assignment. All right? So you're going to post your answer to these questions in the discussion, which is in 3.08. All right? And then, of course, to get full points, you're going to need to respond to at least one of your classmates. So the dates are on the calendar. You've got until the middle of next week, actually, to get your response to a classmate in. But you should have your initial post done by Sunday, a week from today, the 8th. And of course, if you have questions, please contact me.